Good afternoon, everybody. My name is Christine Heiser. I'm with the Pennsylvania Department of Human Services. Thanks so much for joining us for this webinar. We are talking natural gas distribution, so we are very pleased to have some experts in the field to provide us an awareness level overview in preparation for the upcoming National Mass Care exercise. So I can talk a little bit more about the exercise once we're all done with the presentation, but I want to make sure that we have time for this valuable information and any questions that you may have. So this webinar is being recorded. I will be sharing the presentation. Guys, are you able to share the slides afterwards as well?
Sure.
Great. Yeah, I'll also upload the slides so you can have a copy of those. So if you have to pop off, no big deal. You can access those materials later on as well. So without further ado, I'm going to pass things over to our experts. So take it away, Steve and Dan.
Wow, that's the experts. Okay, so good afternoon, everyone. My name is Steve Cook. I'm with UGI Utilities. I'm the Director of Regulatory and Legislative Affairs. I've been with UGI for 36 years and pretty much been through most departments, so have a good overall knowledge of natural gas and UGI. But the true technical expert, Dan Hegel, will be joining me today. He's our Director of Pipeline Safety and Management System. So first, I'd like to extend a special thanks to Christine and from the PA Department of Human Services and Derek Rule from the PA PUC. Thank you, folks, for really giving Dan and I this opportunity. We really do appreciate the opportunity to discuss the basics of natural gas. And hopefully you'll have a better understanding of the natural gas supply chain and how disruptions may prompt the need for mass care services. So we laid out an agenda here today. Truly, we're asking for questions throughout the presentation. We're really here to answer your questions. Dan and I, we live this every day. So we live and breathe this stuff. So it all seems natural to us. No pun intended. But simply, like, we don't know what you don't know, right? So please let us know when you have a question. These slides are designed to really lead a conversation in natural gas. And even if you have some type of tangential question, you think maybe it doesn't apply, don't feel afraid to ask. Okay, so the agenda for today. Natural gas distribution company, I'll go through that, who we are, UGI, and who our customers are. Some properties of natural gas, the basics. Dan will cover the transmission and distribution system, the restoration of gas service, an important part of it, and then, of course, communications during an event. So, Dan, if you wouldn't mind, thank you. So here's just a general overview of the natural gas industry, and really what I'm trying to convey here is just the popularity of natural gas. So the U.S. natural gas industry had 275 million miles of pipeline. That's a lot of pipeline out there, folks. This includes distribution, services, transmission, and gathering lines. And this is a 2022 data, so we've actually added a lot more piping since then. Over the past 3 years, natural gas utilities have added, on average, like 750,000 customers annually. About 60%, and you're going to see maybe 61% of the U.S. homes use natural gas for some type of end use. Now, that translates out to one new customer every minute across the United States, 80 businesses each day. At UGI, we add one customer every 45 minutes. Not quite every minute, but every 45 minutes. And that's every 45 minutes, every day, 365. So again, just showing you, like, we continue to add customers. Moving on. This gives you a general idea. This shows the majority of the households use natural gas in 2022 or 2020. Now, what's interesting about this is it shows 61% of US households use natural gas. But remember, that's only where natural gas is available, and it's not available everywhere. So when you think about it, because we're not bottled propane or in a vessel like oil, or electricity, which serves everyone, where we are, we have even higher concentrations of natural gas. So I'm saying this so that in outage events, the majority of homes along our gas distribution systems use natural gas. All right, Dan, next slide. So what I'm not going to try to, well, I'm going to try not to do today is use a lot of acronyms. Okay. But I have to use one because this is something you'll hear fairly often. It's NGDC, and that stands for Natural Gas Distribution Company. So in an event, you'll hear this, Derek, our friends at the PUC use this term a lot, and it really is it represents a state regulated natural gas utility, which owns the gas lines and equipment necessary to deliver natural gas. So when I say regulated, that means the Pennsylvania Public Utility Commission regulates us, UGI, as well as 20 other natural gas utilities in the state of Pennsylvania. So they oversee us, they make sure we're doing all the proper things, and we report back into the Public Utility Commission. Now, what's also interesting is, oh, you got ahead of me, Dan. What's also interesting is that as an NGDC, we have specific service territories. So we apply for certificates of conveyance, which means we ask the Public Utility Commission, can we serve a municipality? And why that's important is, while it's predominantly the case, it's not always the case, but it's predominantly the case, one natural gas company serves each municipality. So what you don't have is multiple gas lines running throughout an area. So in the case of an event, generally you're dealing with one natural gas company. If it's a very large, it could cross territories, but it's well known the territory. So you'll be working with one or multiple companies, but it's clearly defined. All right, next slide, Dan. So about UGI. UGI, we operate a natural gas utility with approximately 12,000 miles of natural gas pipelines. We serve 684 residential, businesses, and industrial customers, mostly in Pennsylvania and one county in Maryland. We have an EDC, electric distribution company, another acronym out there for you. But we serve 62,000 electric customers in Pennsylvania through 2,600 miles of electric lines. And you can see in the last slide, no need to go back there, but we have specific municipalities in which we work with. So again, all that is upfront. It's actually listed in our tariff. So this gives you an idea of where we are. We're just one of, again, 21 utilities in gas utilities in Pennsylvania, but it shows how we're spread out. In fact, Dan, if you go to the next slide, that little yellow blip is our electric company. But if you go to the next, you can see how our customers are spread out. So, when we have an incident, if there's something going on, you could be in a small area, say it's in the Lancaster area, there's 132,000 customers located there, or it could be sometimes in a larger geographical area with less customers, but it just shows you how we're spread throughout the state of Pennsylvania. Next slide, Dan. Yeah, so 21, I saw the question there is how many natural gas companies are in Pennsylvania, about 21. Again, I'll try to stay high level. There's some municipal owned natural gas authorities out there that are not regulated by the Public Utility Commission, but generally speaking, regulated utilities about 21.
I'll add to that, Steve, as well. There's 5 or 6 large natural gas utilities in Pennsylvania that cover most of the city centers. You have companies like National Fuel, that it's up in the Erie area in the northwest part of the state. You have Peoples Gas around the Pittsburgh area. Columbia Gas, which is NiSource, is kind of in the southern part of the state from Pittsburgh through State College and then over to southern York County. UGI, you see in our footprint, you have Peoples or PECO, which is over outside of Philadelphia, and then Philadelphia Gas Works, which is in the city of Philadelphia. So those are the big players across the state. And then, as Steve said, there's some smaller municipal type outfits that have a smaller customer base.
Oh, great, thanks, Dan. So who are our customers? So we categorize them generally in residential, commercial, industrial. But something I'm going to point out here as we go through this, and just from a mass care perspective, I think you need to understand is that our residential customers, they are employed, through businesses. So residential customers go to work in whether it's industry or commercial, retail, commercial. So remember, when we have an outage, something to think about is that you have the outage area, right? So we may have a clearly defined scope of the outage, but if you live in that outage and you don't have, say your natural gas is shut off, you may not be able to go to work. And that commercial enterprise may be outside of the affected area or the industry. And likewise, so you may have natural gas at your home, but your business may be closed. So something to think about, that while we define the outage area, there's some bleed over, there's some crossover as far as who's affected. And again, I'll get into this, but that affects, say, a hotel, that employees don't show up to work, or vice versa. So start with residential customers, and really the goal here is just to kind of go over the basic appliances that are in a home. So the primary, it's heating. So you have furnaces, boilers, space heating, and fireplaces. You have the water heating, very important. And then of course, cooking, clothes drying, generators are gas generators, natural gas generators that supply electricity in case of power failures. And then you have pools and spas. So something to know about residential appliances. It's true for other appliances, but on residential appliances, there's just many that are out there. So you have most of your new equipment is electronic ignition, which means you need electricity to power it to make it work. Okay. So if there's a power outage and that's coupled with a natural gas outage, that's a problem. Even if it's, quite frankly, a power outage, your natural gas equipment may go down. So these things are coupled together, and depending on the type of equipment, they could affect each other. So it's, I just want to bring that up to this group, that it's, there's very few pieces of equipment are just standalone. There are some pilot operated natural gas water heaters that are natural draft, but they're becoming less and less as we go along. So most equipment requires power. Commercial customers, something to think about here. Commercial customers, that could be, restaurants and schools and airports. So I know, I serve on the board of the Red Cross, right? So, some things we think about is where are, care facilities in case of emergency situations. Well, a lot of times you say, well, where are the schools, churches? I don't know, I don't even have churches on here, but, a lot of these areas that you normally would amass people together, to provide them some type of safe area to be in. Well, in an outage area, most of these customers utilize natural gas. Something I say oftentimes, about hospitals, in our world, this is a fun fact, but there's not a single all-electric hospital in the US. They always have some type of additional fuel. So remember, a lot of these folks, the fire stations, the factories, again, going through that, even airports, government agencies. So, when we have a natural gas outage, it truly affects everything. So just put some thought into that, as well as there's assisted living facilities, laundry facilities. Think about prisons and sports arenas, again, just trying to give you a good idea of how disruption affects the multitude of commercial customers are out there. All right, Dan, anything else to add? All right. So now industrial customers, and this one's interesting because for an interruption of natural gas, one thing that we know, I'd like to think most people know, but power generation, electric power generation, almost 60% of electricity generated is from natural gas. So depending on the type of interruption, if this would affect a power generating facility, you could be out of power. So without the natural gas, you're not going to be generating electricity. Which is say either you're going to have a brownout or an interruption of service. There's various levels, but certainly at 60% electricity generation, having an outage to a natural gas power generating facility is important. Other things to think about, refuse trucks, okay, garbage trucks essentially, a lot of the fleet. In fact, I think I read at some point that like 60% of the new trucks coming off the assembly line are ordered or natural CNG, compressed natural gas, or natural gas vehicles. Distribution fleets. We have in our territory, we have UPS just had like one of their super hubs, like the largest on the East Coast. They have a fleet of CNG natural gas vehicles. So interruptions to natural gas to those facilities interrupts UPS deliveries. Now these are a couple things that are just unique to our service territory, but there's it's located close to me. US Durham has a plant in Lancaster that they have the capacity to produce basically all the couscous that the US eats in a year, right? So and they're a natural gas customer. So when that plant goes down, it stops the the production of couscous, right? As well as, I'm sure most everyone heard of Hershey Foods, right? So another one of our big customers, an interruption to Hershey Foods creates a big issue. And there's another one I don't have listed on here, but Kellogg's. I think one of the 3 Kellogg's plants in the U.S. is in Lancaster County, and an interruption to that plant could severely interrupt the supply chain. And last is an example of GlaxoSmithKline. They're a customer of ours in the Marietta area, and each year, 1 in 4 Americans, are immunized by vaccines that are produced at that Marietta site. So again, lots of implications. Disruptions can ripple on through many of the through much of the supply chain. All right, Dan. So, natural gas. Properties of natural gas. Tasteless. I'm not sure why you taste natural gas or why you taste gases, but anyway, it's tasteless and it's colorless, okay? It's actually odorless too. We add, the distribution companies adds an odorant to the gas. All right, it's called mercaptan, and it's what makes it smell like rotten eggs, and that's just so that the public can be aware if there's a gas leak, they can smell that sulfur or that rotten egg kind of smell. Something else is natural gas is not toxic. Okay, what is concerning though is if there's enough natural gas in a room, it could displace oxygen. So, sorry, someone's knocking at my door. So it displaces oxygen. So obviously that's a problem if it displaces too much oxygen. Now, another characteristic of natural gas or property natural gas is specific gravity, and this is important to know. So natural gas is lighter than air, so it has a specific gravity of 0.6, which is really the ratio of a gas density to air. So when it's less than 1, it's lighter than air. For example, propane, another gas that's oftentimes confused with natural gas, has a specific gravity of 1.6, which means it's more dense than air. So why I say that is obviously natural gas rises, but when ventilating, we ventilate natural gas through natural methods, and what we do is use help me out, Dan. I guess like fans and whatnot to displace propane or to dilute propane from an area. All right, this is more the chemical composition of natural gas. So the primary component of natural gas is methane, CH4. So when properly combust, the byproducts in combustion are carbon dioxide and water. Also, another property is it has a flash point or ignition range of roughly like 1100, 1200 degrees. So the source of ignition has to be fairly hot. Now, I say this, if we go on to the next slide here, I say this because natural gas, there's a very specific and narrow range in which natural gas will ignite. A lot of folks don't know this, okay? So it's really about a 10% range. So if there's less than 5% natural gas in a room, in fact, there's 3 components that require for ignition. It's natural gas, it's oxygen, and it's a source of ignition. So if it's too lean, which means less than 5% natural gas mixed in a room with air, natural gas won't ignite. Between 5 and 15%. So remember, you need to have between 5 and 15% ratio of natural gas with air. All right. You need to have air there, okay, oxygen, and you need to have a source of ignition. So only when those 3 are together can you have ignition. Too much, above 15%, you won't have ignition. So again, hopefully you guys find that important. That's why sometimes we've got your gas grill, and you try to light it. It doesn't light because you don't have that right combination. Anyway, next slide. I think we're getting the dance slides now. So turn it over to Dan.
Thanks, Steve. So wanted to give an overview of the natural gas pipeline systems, and I took this diagram from PHMSA, and from PHMSA's from the Department of Transportation, and PHMSA, the PUC acts on PHMSA behalf to enforce the regulations. But PHMSA shows this kind of overall diagram of natural gas pipe systems. So we start over on the left-hand side and we see where natural gas comes from. Typically, it's naturally derived from wells that are drilled down, maybe even a mile or 2 underground, and they bring up the natural gas. They can store it in storage facilities. They do some of the drilling for natural gas offshore. A lot of it comes from the Gulf of Mexico region. And then they also can bring in liquefied natural gas. You can cool the gas till it goes into a liquid form, and they can ship it in tankers, or they have LNG storage facilities as well, big tanks that you may see along the highway, and they will be able to vaporize that gas and put it into the piping systems. So typically they will process the natural gas when it's coming out of the ground, and they're pulling the different types of gases that are blended with it, like propane or butane, other heavy hydrocarbon type gases with it, till it gets to a pipeline quality natural gas. A lot of times what they will do is then compress the gas to get it at a higher pressure to be able to flow through the pipelines and supply the areas that are looking to be served with natural gas. You can see there are some large customers that may be supplied off of a high pressure transmission line, like a electric power generating station or a large industrial customer. But then you have what they call like a city gate, and I'll get into some of this detail as well, but it's where the natural gas utilities, LDCs, come into play, where they distribute the gas through their own piping systems to the end user. So small manufacturing customers, commercial customers, residential customers, and some of the other natural gas vehicles that Steve mentioned before. Probably appreciate that there's a spider web of pipelines throughout the country and throughout our service territory that goes to where our customers are. And so I want to give a little more description here of the system and some considerations. I'm not going to read through this whole slide. Go ahead, Steve.
I'm sorry. Could you go back? I just want to make sure. Yeah. So they mentioned a compressor valve, compressor station. What's important to know is our system of natural gas is a hydraulic system. So we compress the gas, and you maybe initially, for a transmission company, it's 1,100 pounds, right? And then that gas, that's what drives the gas to the end user. So when you turn your stove on, you're basically opening a valve to atmospheric pressure. That's what drives the system to push the gas from that high pressure to the low pressure. So it's all being driven by that differential in pressure. So I just want to make sure they understand that. So it's pressurized, it moves throughout, and that's what moves the gas through the pipeline system.
Thanks, Steve. And so natural gas supply considerations. Again, this information will be available, but the point of this is system reliability. Many of the gas lines going across the country and across locally, our distribution system has multiple points that it's connected to. And we do have some single one-way feeds that if you have a disruption on the pipeline, everybody downstream of that line is going to be affected. You have other circumstances where you have multiple pipes coming into a network. So if you have a local disruption, it doesn't affect the rest of the distribution territory. You can backfeed it through other pipes and be able to maintain some reliability of supply. You may have a localized outage, you have to shut off some local valves to isolate a situation, but you don't lose the whole service territory. Now, that's also dependent on the lines that are involved in an incident or outage. You may have somebody that digs in and hits a line and you have a gas emergency, or you have a leak where you have to shut the line down. Those circumstances, it could be just a local line that's going to a dead end cul-de-sac, and you may affect a handful of customers, or it could be a main trunk line, high pressure line that's affecting hundreds, if not thousands of customers downstream. So depends on the lines and where you're at, but generally there is some redundancy in the system, and that's what we're just trying to highlight here with some of this information and that you could read more about. We also have what's called line pack. So as Steve mentioned, you have higher pressure gas lines that are then reduced down in pressure to medium pressure gas lines, and then ultimately at a customer's appliances, you're down to about 1/4 pound of pressure. You may be starting with 1,000 pounds in the main transmission line. So if there is a disruption, it may take a little while for the pressure in those pipelines to actually dissipate through usage until there's no more gas in the line. So depending on how quickly you can get to an issue and repair it, you may be able to recover without large-scale outages because of the line pack that exists in the system. So break down the big picture view of gas facilities into kind of 3 categories. The first we'll get into is transmission and gathering pipelines. Then we'll talk about our distribution mains. Mains is a term we use for pipelines. And then customer service lines and meters. So transmission facilities, these transport gas. Historically, most of the gas in the country came from the Gulf of Mexico region, Texas, Louisiana, big producers of natural gas. But many of you should be aware, especially in the last decade, of the Marcellus Shale. It's a rock formation, and it comes across a large part of Pennsylvania, and they found large deposits of gas that the drilling technology has advanced, and they could actually drill down 1 mile into the ground and harvest this gas. And most of the gas that we use regionally in the Northeast is supplied right from Pennsylvania, right from the Marcellus gas regions that we have. So these transmission and gathering lines are gathering the gas from these different drill sites and wells, and they'll compress them. And then they go through what we call a transmission line. And there's transmission operators and companies that have interstate pipelines that go to the country and the city centers where we're at. These go up to typically maybe up to 1,400 pounds of pressure for natural gas. There is a public national pipeline mapping system. The website is listed below here. And this is just an example. It actually goes by county, and you can select different variables on map layers to turn on. So an example here, we have up in the Stroudsburg, Mount Pocono area that we're showing, and we selected gas transmission lines or hazardous liquid pipelines. That those aren't ours, but they are part of this national mapping system. So you can see that there are some high pressure main trunk lines of gas transmission that traverse across the county here. And again, this is public information. We're required as a utility to report annually on our transmission lines that we operate. But largely, it's the larger transmission companies that have the bulk of the high pressure transmission lines that go across the territory. So this should be a good resource if anybody's, curious to use this. If you do have an outage and it's gas related, or you have LNG, liquefied natural gas plants, and some other interesting map layers that they have on this national pipeline mapping system. All right, next, I mentioned earlier on the PHMSA diagram, the city gate stations. This is a pressure regulating station. It takes it down from those high pressure lines, and it puts it into a lower pressure that we use in our gas distribution. And it helps feed the main trunk lines that we have of our distribution system. So you may see these across the road, where you're driving, you'll see a bunch of pipes sticking out of the ground and other equipment. This is a heater that heats the gas up, because when you're reducing the pressure, it naturally cools the gas. And you have other equipment and monitoring equipment here. We meter the gas, so we'll purchase it from the transmission companies and then sell it to our customers. So wanted to highlight here, this is pretty complex piping systems, and there's valving and there's components here that we monitor. And if it is a large disruption on a transmission line and an outage, we're going to have to physically visit these stations and maybe manipulate some of the valves and monitor the pressures and do what we need to do to try to keep our system in play, or shut the system down and isolate it if we're going to be losing pressure. Next, we have our distribution facilities. These are distribution mains and regulator stations. We distribute our gas across our service territory. Often they follow roadways, just local, state highways, all the way into neighborhoods. Our lines typically follow the roadways, but not always. Sometimes going from one territory to another. Steve showed that we have a pretty wide footprint, and a lot of our footprint is connected. So you may have cross-country lines they're going through kind of remote areas in right-of-way type situations. But these lines are modern, made of plastic that we've been replacing. Typically operate a UGI's distribution system around 60 pounds of pressure. And then that 60 pounds of pressure will go up to the house and then get regulated down again when we're talking about customer meters and facilities, which I'll get into next. So these are also pressure regulating stations here. These are certainly a lot smaller than the city gate station diagram that I showed. You may notice these in your travels as well. These are actually regulators. These are mechanical devices that spring loaded, that take the pressure and only allow, you have a higher pressure coming into one side. It regulates the pressure down to a lower pressure on the outlet side, and that's the basics of it. And you have some relief valves too, so that if the pressure would build up, they would vent the gas to the atmosphere to prevent the downstream piping from being overpressurized. These could be located above ground. Typically, they could also be located below ground in pits. There's some of those as well across the service territory. And then finally, we have the gas service lines that go and serve the end users, our customers. So we have service to homes and businesses, as Steve covered before. It's a step down in pressure. Typically, it's going from 60 pounds down to, this is actually 7 inches of water column. It's a measurement of pressure that we use. It's equivalent to 1/4 pound of pressure, basically. And that's what your appliances will typically use in a residential application, your furnaces and stoves and water heaters. Some commercial and industrial customers take higher pressure for sure to operate their equipment. Maybe 60 pounds, maybe 100 pounds, depending on the application. Certainly large electric generation facilities and other manufacturing industrial customers will take higher pressure to operate their industrial equipment. So just a little more on what a gas service line actually is. This is kind of a cross-section view a little bit. You can see a car on the roadway here. This circle is actually a gas main that is paralleling the roadway. And what we do is we connect to that gas main, and we run an underground service line to a property, and then we come up above ground to a meter. From that meter, it's typically regulated down to that 7 inches of water column or quarter pound of pressure. And then the customer on the outlet of the meter will own the fuel line that actually runs inside their house and goes to their equipment. So that would be customer owned. We stop our ownership as a utility at the meter. We have other equipment. There's shut-off valves on the service line if the meter's inside. If not, the valves are typically located right on the meter set itself, and I'll show you that. We also have some safety features on more of the modern lines called an excess flow valve. So if there was a leak or somebody hit a line, it would kind of trip this excess flow valve and stop the majority of the gas flowing in the line as kind of a safety measure there. So these are a couple pictures of meter sets, residential or commercial. These are different types of meters. This is probably a typical meter you may see if you have natural gas at your house. You're used to seeing. Here's a regulator, so the gas is coming up out of the ground. There's a couple valves here, and takes the pressure down, goes through the meter, and then on the outlet would go into the house to the appliances. This picture below here is a larger, different style of meter set with a little more piping and equipment for more of a commercial application. And then here's another meter installation. This is actually on a low pressure system. It doesn't need a regulator because we regulate the entire mains down to a quarter pound of pressure. And it is just metering the gas, and then the outlet of the meter. There's some valves here that could isolate the customer side, and this would be a fuel line going to a customer's equipment. Okay, so I want to talk about what happens actually if we have an outage, natural gas, and what we have to do to restore our restoration procedures and restore gas to our customers. Very different than electric outage. We're all used to thunderstorms coming through, knocking down trees that'll take out a power line, and you'll be out of power for a little bit of time. And when the electric company repairs the line, then your power comes right back on and you're good to go. Unfortunately, it's not that easy on the natural gas side. So typically what happens when there's a natural gas outage, we work as a utility to identify the scope of our outage and verify the customers and non-customers. Steve mentioned it's a hydraulic system. We have computer software that models the flow of our entire natural gas distribution system with all the pipes in it and simulates the usage and where the flow may be. So we know if, let's say there's somebody digs and hits a line and we have to shut it down, we can then tell how many customers are affected and how many valves we have to shut down to isolate that system. So we do a lot of that verification up front, try to identify the scope of the outage. We have our call centers, our customers are calling in and saying, hey, my furnace isn't working anymore, or the gas doesn't seem to be on. And we try to target those as well and communicate back to our customer base through a variety of media channels. We email and text, and we have other communication ways, public service announcements, to get in contact with our customers and notify them of an outage with those communication. But what we have to do is we have to go to each customer's meter set or service line, and we have to shut it off. Steve mentioned that some of the older equipment is still pilot operated. Some of it is electronic ignition. So having that mixture of appliances in our customer base is critical, because you can't just reintroduce the gas in the line, because if the pilot light had blown out, you now would just be introducing gas into the structure. It's not being burned off by that pilot light. So you have to shut off every single customer that's affected in that outage. Let's say there's an outage of 100 customers. you physically have to go to every customer, verify, shut off their service lines. Then you go and you have to make the repair to whatever damage occurred or disruption. You may have to purge any air out of the gas line. If somebody hit the line and it's exposed to the atmosphere, you have to get all the air out of the line so that it's just straight natural gas. So you don't have a different mixture of air to gas ratio, Steve mentioned earlier, that would be unsafe. Then once the line's been repaired and you purge the gas, the air out and the gas is back in the line, you now have to go to each individual customer and turn on their gas and physically go light their appliances or verify that the electronic ignition in their appliances is operating safely. And you have to find all the appliances and make sure everything's safe and there's no leaks and there's no issues there. So it takes a while for that to happen, and it is an individual type process. Sometimes in a prolonged outage, people leave their homes. They go elsewhere outside of the territory. So you don't have an opportunity to light up their appliances right away. So their service remains off until they come back in the area, coordinate with the utility to get a service technician out there to light their appliances. So it's a lot of manual coordination, and depending on the size of the outage, that coordination and communication compounds and grows. And we actually, large utilities will request for mutual aid from other utilities, where they will send resources, technicians to your area to help with this shut off and relight process as you go through a large outage.
Hey, Dan, let me just add, and picture in your mind, like generally these outages don't happen on, a blue sky, 72 degrees, it's the middle of the day. These outages often occur at the worst possible times under severe weather events or 2 o'clock in the morning. So remember, when we go out and we have to shut everyone off, we shut everyone off in our known affected area, as well as, Dan, correct me if I'm wrong, but we have to verify, like, even adjacent customers, make sure that they don't have gas. So it's a lot of manual walking around, verifying, again, sometimes in bad conditions in the middle of the night. So it takes a long time, as well as when we reintroduce natural gas, after we get through all those other bits, right? We have to do it in sections. We don't just like turn a valve and everyone just magically comes on. We have to go through and introduce it in a reasonable fashion. And oftentimes we use public service announcements and other ways to communicate to customers that they must return back to their home. Okay, because we need them there because we have to get entry, as well as, and I think, Dan, you're going to go through like some of the light up concerns that we have, or turning folks back on.
Yeah. So it's a good segue, Steve. So I mentioned earlier that the utility does not own the fuel lines downstream of our meter that supply the appliances that our customers use. So when our guys go in and are attempting to relight some of these appliances, they may find issues, code violations, that a furnace isn't drafting properly and could be producing carbon monoxide, or it's not up to the International Fuel Gas Code, or there's unsafe conditions or leaks on the customer's fuel lines or equipment. Or it may be a commercial application. You go into a restaurant and you have no idea how to light some of the specialty equipment, and you need to enlist the help of their maintenance staff. Or certainly industrial applications, we typically rely on the maintenance folks to handle their equipment and light their appliances, light their equipment. So if we find issues, we have a tagging system, and we would, red tag is a serious concern, and we're saying we are not going to light this appliance back up, and you need to have somebody come out and fix it. And then a municipality would actually get a copy of this red tag so they can send one of their code enforcement inspectors to go and make sure that it's been done correctly, because typically the municipalities are governing the fuel lines and the codes and standards that go with them. So in a large outage situation, especially in the wintertime, it's unfortunate because there's a disruption in gas service. It's unfortunate or fortunate, depending on how you're looking at it. We send our technicians out. We go to get somebody back in service and light their furnace up, and we find that there's code violations with it. we can't light up their furnace. Now they're scrambling and trying to get a mechanical contractor or plumber to come in and fix their furnace so they can get their heat back on or water heating back on. Um, it further complicates the process, but it at least provides some eyes and gets a safer situation that customer may not even be aware there's an issue with their equipment until somebody is specifically looking at it. I just quickly too, I go through the last bit here. You know, we have other notifications and door hangers and things to try to coordinate communication if people are not home, especially in a prolonged outage where a lot of times people they're either at work or maybe they go into a relative's house or something where they do have heat, that type of thing. So a lot of different communication avenues that we try to take. I want to kind of finish out here with incident management. A lot of you are probably more the experts than we are, but UGI is a gas company and several of our peer gas companies have adopted the National Incident Management System program and specifically the incident command structure. So a lot of you are familiar with this. If there's a large outage, we're trying to coordinate with other emergency agencies. And that's what we do. So UGI, we have our incident command structure and it follows the guidelines, and we've adopted this and done a lot of work over the last decade to try to get into this structure here, where we'd have an incident commander and we would have all the safety officers and liaison officers, public information officers. Then we'd have our general staff that's specifically focused on the natural gas side of the incident as we're trying to restore our system and restore service to our customers. But as a reminder, we would have a public information officer that's kind of the conduit for sharing information with external stakeholders, including the media. We'd have a safety officer making sure that our systems procedures are being followed and kind of coordinating multi-agency safety efforts. And then the liaison officer would be coordinating efforts with other agencies like DHS and Red Cross, FEMA, PEMA, whomever, to make sure that we are all working together to fix the issue. And for us, generally, incident command, the way it's designed, it'll grow with the incident. So our first responder, that's the first one to show up on site that says there's a gas leak, will be that incident commander. But as their supervision show up, that chain of command will move up. Often we're working directly with the fire companies or fire chiefs that will take on that role, and they'll have UGI focus on the gas side of the incident, but coordinate activities to evacuate people if needed, or help get people away from an area or shelter or whatever the case may be there. And that's typically for smaller outages that are managed, locally with the utility and 911 services there. But we focus on life safety, incident stabilization, and then property conservation in kind of our procedures. So with that, we left a little bit of time here. I know we shared a lot of information, and we're hopefully this gives you a better understanding of natural gas and how it's distributed and some of the considerations if we do have a large outage and a kind of a mass care response to disruptions in natural gas supply. So Steve and I'd love to take some questions or elaborate on anything, and hopefully this hit the mark for everybody.
Great information. Really appreciate the overview. I know I definitely learned some things. Can you talk a little more about the mutual aid agreements within the industry? What do companies help each other out with, or what does that look like?
Sure. I take a stab at this one, Steve. So UGI belongs to a couple industry organizations. The American Gas Association is more of a national agency, but regionally there's a Northeast Gas Association. So we have coordination through the NGA where we have mutual aid contacts for each company, and we will generally work through the Northeast Gas Association and provide the details when we actually make that call for mutual aid to say UGI has a ongoing outage and we're going to require X amount of people to come in for this duration in these defined service territories and to help with relights. And these are the qualifications that the technician should bring. These are the equipment and vehicles that we're looking for. This is the span of control for supervisors down to technicians that we would require. And a lot of that is actually, we drill on that often, and we have now consolidated consistent forms, and we say, okay, we need 100 extra technicians to come in for 3 days to help with our relight process, and we anticipate needing them from here to here. Other companies will respond back and say, yes, we can provide 16 employees and 2 supervisors, or we can provide 10, or we can provide 3. So we'll try to coordinate through that process and say, yes, we will take, you 4 companies, send us your employees, and here's the logistics around it. And once they get in, we will work with those resources and give them assignments, customer lists regionally to go and either shut off and then eventually restore the service depending on where we're at in the process. Certainly UGI, with that big footprint that we have, we start internally with our own employees to try to move them across the state to help in a region. If we have an outage in Lancaster, we may be moving resources from Wilkes-Barre and Harrisburg and the Lehigh Valley, all to try to coordinate what we can within house. But larger outages, I would say typically larger than 1,000 customers out at once, we would generally have to look for a mutual aid to keep that timely.
Yeah, and that's a really great question, because while we have a fairly large complement of folks, these are very specialized jobs. So you just can't go to a local plumber. These are, operating qualification tasks that they have and skill sets. So truly, it's only our other companies, the other natural gas companies within the state, that have the resources available to utilize. So we really do lean on each other as we go through that process.
Another question I have, and this might be a shared question from some of the other folks we have on the line, seeing the audience, is there any way to find out who the customers are in a given area, or how to know which facilities might be impacted in an outage, other than asking each individual contact? And I'm thinking, if I'm the Red Cross and I know I need to set up multiple shelters, if I don't already have that information, is there any way to get that with, aside from talking to each individual facility?
Sure. I was going to say, well, we have that information. Certainly, contacting us, we'd be happy to provide that information as best we can. Once an outage is defined, like the scope of the outage, we know the number of customers within a specific territory. So certainly we could go through our customer list and find that information. Yeah, great question.
And it will be different every time. I mentioned, we have our distribution system, a spider web of pipes, and it really depends on where the outage is or what the nature of the disruption is. Typically, we're just dealing with kind of localized disruptions. If there's a leak where we need to shut something down, or somebody hits one of our lines, we have to shut it down. We a dozen customers, maybe up to a couple hundred customers. If it's a larger supply issue that's coming from a transmission company, it could quickly go to thousands or 10,000s of customers. And you generally, as an industry, because of some of the redundancy, that hasn't happened, knock on wood, but the potential is certainly there. And you see kind of larger, more public outages, Merrimack Valley. That's the public one over that happened a few years ago, and we actually sent some of our resources up for a couple of weeks to help with the restoration of those services. So it depends on the outage, but the local utilities would be the ones that would have that information.
So let's go there. When we're talking about a large scale disruption, a large scale outage, because that's where we're going with the upcoming exercise, paint a picture for us. What is the impact on communities? What is the impact on people's lives? What is the impact on our supply chains? What would you expect that we would see?
I could start, Steve. Steve alluded to that they don't typically happen on sunny days when everything's fine. And really, for gas utilities, is very different winter operations versus the rest of the year, because heating is the primary use of natural gas, and certainly water heating for our residential base at least. And without heat, it causes a lot of issues, as you can imagine. And without heat in some of the schools and without restaurants having natural gas to cook, and then the supply chain disruptions and the kind of the cascading effects along that goes along with that, would be substantial. Now, parts of the service territory, because of the nature of the network of pipes, not UGI wouldn't lose all 700,000 customers that we have necessarily, because we have different supply from different transmission companies. But a large disruption from one of these transmission companies could take out a couple 100,000 customers potentially, not just for us, but then similar of our neighboring utilities. And it would be pretty substantial. We would need federal aid. We would need mass coordination of how to feed and shelter, and keep people warm, in the wintertime operations. I would see a major impact to everything if we had a large scale prolonged natural gas outage.
Are you able to do prioritized restoration during outages for congregate care facilities, critical infrastructure, that sort of thing? Can you talk about that process?
It's a good question. We meant to cover some of that. Some of it is hydraulically driven. So if we say, okay, the gas line's back up and running, let's go and then light our customers back up. Some of it depends on the physical layout of the pipelines and where the gas is flowing to. So it's not easy for us to just cherry pick and say, we're gonna light you up and light you up and light you up. We may have to strategically introduce gas, purge it into service, segment by segment. We would try our best to, identify critical facilities and try to get those up and running from a priority standpoint. But it wouldn't be clean enough for us to just only be able to target those, because of the hydraulics of the system, and getting the gas molecules to actually flow to that end customer may have to be some iterations before we can push gas back out into our service territory.
Makes sense.
Yeah, and again, just another complicating point that, those employees that work if they're in that area, so if it's hospital, people that work at a hospital, we tell folks we actually prefer that they stay at home when we do the relay process. So, it's kind of a fighting of resources, right? So, for homes, we want to get folks relit as soon as possible, but they also have responsibility to be at the restaurant, right? We'll need some folks there too. So it's a difficult balance.
What other questions do we have from the audience?
It's the Friday afternoon rule though here, so it's Friday at 2:00.
I think I just asked 8 questions. So
yeah, no, great questions.
Last chance, anyone?
I would just mention too, our winter operations, if we have small outages, like I mentioned before, let's say we have 20 homes or something that are going to be out of natural gas for an evening while we make repairs to a pipeline. Locally, we have a small inventory of electric space heaters, for example, and we may be able to accommodate those 20 homes and give them some electric space heaters so that they can keep their homes warm and their water pipes don't start freezing up and bursting and causing other issues without having heat in extreme cold temperatures. But once you get beyond, a couple dozen customers or maybe 100 customers, that becomes a challenge. And that's where we, seek assistance from other organizations and trying to get sheltering and other means coming in. So it quickly becomes an issue if you get above 100 customers or so, and we're really needing that coordination. So if we talk about tens of thousands of customers, it's well beyond what the utility can handle, and there's coordination there around the operations and then the scheduling and the repairs and restoration of service, but the mass care side is really out of our hands. I see a question in the chat from Craig Campbell. Understand that facilities such as hospitals must have an alternate source of power besides natural gas. How does that factor in the local, if the local electric is also natural gas generation? That is it's a valid point, and it's one not many people think about. So yes, if the electric grid is largely supplied by natural gas, and you don't have electric, it could take out both supply points at once. Typically, natural gas is used as the primary source, but electric, if the electric goes out because of a storm, you typically would have natural gas as a good reliable backup. But if that natural gas supply is disrupted, you're going to have potential disruptions to the electric grid, and the electric grid is going to be challenged in that situation, given that over half of it is supplied by natural gas, and it's really dependent about that mix in the area on how the electric grid is holding up and how the natural gas disruption is.
Yeah, also note that most of our customers have backup sources of energy. They're not long-term backups. They're short duration. Sometimes it could be just a couple of days or maybe a week or so. So depending on the severity of the outage, we could go well beyond that, and it creates another disruption. So just thought I'd mention that.
A couple other questions I see in the chat here. There's a cyber attack. Are some safeguards in place so that your entire coverage area is not affected? So it's certainly something that we have been more aware of, and we've been trying to plan for. I know PUC, Dan Searforce and the TUS team have done some exercises around cyber attacks and extra controls in place. We do have monitoring and computer systems that we use for our system, but we also have operations and contingency plans for outages ourselves and to try and maintain our system. Our system is very mechanical. These regulators that take the pressure down it's a mechanical device, but there are some electrical components to it. So we're not immune to a cyber attack by any means. It would certainly complicate some things if our systems were down, but that doesn't mean we can't respond to emergencies, and we have other contingencies in place to be able to do so from a communication standpoint and an emergency response standpoint. I see Dan had made a comment here about the electric grid too. If gas is out at a local level, the electric grid, similar to the natural gas distribution system, there's many connections and kind of spider webs together, and there's some redundancy in the reliability of that grid by design. So it's it wouldn't necessarily just immediately take out the electric grid as well. It depends on a lot of factors and where the power plants are located and what they're supplied from and where the outage is. But certainly we do want people to be aware that there is a large component of natural gas, how it affects the electric grids. Okay.
Well, thanks so much, everybody, for the questions. And thank you so much to Dan and Steve from UGI for the insightful presentation today. I know this background information will definitely come in handy later this month during the National Mass Care exercise. And just for everyone's awareness, the Public Utility Commission is also conducting a simultaneous tabletop exercise on the Tuesday of the exercise week. So excited to see you guys get a chance to work through some of those restoration issues. It'll be a big big challenge to tackle, but it sounds like you're up to it. So looking forward to seeing many of you on site at Shippensburg University during the National Mass Care exercise the week of May 20th. So please reach out if you need any additional information regarding participating on site there during the exercise. I'll put my email address in the chat, and you will receive a copy of the recording and the PowerPoint slides. Once I have them available here, I'll send it out to everybody. So thanks for spending part of your Friday afternoon with us, and have a great weekend, everyone.
All right. Take care.
Thank you.